Welcome to when can we transform nonlinear equations into separable equations if we want to complete that question. So recall in the last video, we could transform Bernoulli's equation using the same y1 as we used for non-homogeneous linear. So for Bernoulli equations, y prime plus p of x y equals g of x y to the r. We used y equals u times y1, where y1 is a solution to the homogeneous y prime plus p of x times y equals 0. But the question now is, that was very specific for Bernoulli's, that we could use that y1 because Bernoulli's looked more or less like a non-homogeneous linear equation. So now what if we just have the general form y prime equals f of x, y? So what we really need to do is see what can we use for y1. So let's go ahead and assume that y equals u times y1 is a solution to y prime equals f of xy. Then what that means is y prime, which is the derivative of u times y1, is equal to f of x comma u times y1, or u prime y1 plus u times y1 prime is equal to f of x comma u times y1. If this equation is separable, which is our goal, so if this equation is separable, then we should be able to rewrite it as u prime is equal to, I'm going to do this a different format than usual. Let's do h of u times g of x. So usually we would do the h of u on the left. We'll go ahead and put it on the right-hand side. This way we can always divide by h of u. So let's go ahead and just rearrange the equation. So rearranging the equation, we have u prime times y1 is equal to f of x comma u of y1 minus u y1 prime. And we could always divide through on both sides by y1. So we'd get u prime is equal to f of x comma u times y1 minus u times y1 prime all over y1. Now recall that y1 and y1 prime are a solution, or are assumed to be just functions of f. Sorry, functions of x. At least that's what we have seen previously with our y1s, and so we're going to leave that. So instead of recall, maybe we should put note. So when we're doing our separation of variables here, if we can rewrite that f of x comma uy1 as a function of q times y1 prime, then we could factor out a y1 prime and have something just in terms of u. So the ideal situation would be if we could factor out y1 prime from the numerator. So that all that is left is in terms of u. So leaving only a function in terms of u. So in other words, what we want, we would like it if f of x comma u y1 can be written f of x comma u times y1 is equal to some function q of u times y1 prime. If this is true, I'm going to put a star here. This is sort of what we are hoping to hold. If this is true, then our differential equation becomes u prime is equal to our original equation. We had f of x comma u1 prime, or f of x comma u times y1. That is now our q of u times y1 prime. And then we'll subtract off u times y1 prime and divide by y1. So we have u prime is equal to q of u times y1 prime minus u times y1 prime, all divided by y1. Or u prime is equal to, pull out that y1 prime from the numerator. We have y1 prime over y1 times q of u minus u. And this therefore separates as u prime over q of u minus u is equal to y1 prime over y1. At this point, we have the tools to solve. We could at least solve this and leave it in terms of integrals, if nothing else. Right? So from here, we can solve. Just a quick note that at this stage, we technically would have a constant solution. If Q of u minus u is equal to 0, right? That would mean that Q of u equals u. So if we have a situation where, sorry about that. If we have a situation where Q of u naught is equal to u naught, then we would have constant solution u is identically equal to u naught. Right. So again, with separable equations, we do have these equations that don't pop up in the integration. All right, so essentially what we've gotten from what we've done so far is if we can find y1 such that f of x comma u times y1 is equal to Q of u times y1 prime for some function Q of u. If this holds, then y prime equals f of xy can be transformed into a separable equation. So at this point, the tricky part becomes, how do we find such a y1? So in the next video, we will learn a very special case or a very special type of nonlinear equations for which y1 can be just simply x. And that's really all we'll be focusing on for this section.